All right, hello everyone. Joe Fairley from Ascent Fabrication here. Just working on getting us live here for our Fabrication Friday. I wanted to show you guys my screen here today to kind of go over some of the options and pros versus cons for in-house and digital central fabrication services for prosthetics and orthotics. Kind of go over what is available today. Just move the camera around here, so bear with me for just a moment. I'm going to try to get our screen available. Let's see here. Don't you love live? Let's see. Just trying to get the screen up. Let's see. Window capture. All right, there we go. Pardon me while I'm still getting this set up here. Thank you for attending our Fabrication Friday event here. We do this live every Friday at noon EST. Sometimes we get some other things going on, so we might end up being a little bit later in the day. Maybe we end up on some Pacific time a couple Fridays. But if we don't do it a certain Friday, we will end up putting something out there for that week. So now, just getting everything optimized. All right. So let's take a look at some different options in prosthetics and orthotics today. So with Ascent Fabrication, your general work order workflow is going to be sending us a 3D scan with some patient health information that is de-identified, and then also including certain measurements, as well as indicating on the scan itself kind of where you want either certain clinical modifications to happen or buildups over areas for cushion areas for our foam flex air flexible inner socket. So again, kind of how in terms of their efficiency for you day to day, as well as the cost and time savings that they actually provide for you. Some solutions out there are extremely usable, might be a little bit more higher cost. And in some cases, you might already have some of these systems existing within your clinic today, and it's sort of tough to go back and adopt any new technology, new software, new programs that might end up being a better fit for your clinic. But utilizing what you already have in your clinic is still going to be useful for your workflow. When we talk about different 3D scanning technologies, so let's get into 3D scanning for a moment. What is a good looking 3D scan? We can actually possibly show you that also. Let's see if we can get into showing you a different screen. And we can show you what a good 3D scan actually looks like. Let's get a good 3D scan up and running for you. All right, so we are opening Autodesk Mesh Mixer right now. Mesh Mixer is a great tool to look at 3D scan data, although it is quite difficult sometimes to actually work with. So maybe I can just center that for you and we can take a look at this. All right, so here we have Autodesk Mesh Mixer, and let's talk about what a good 3D scan looks like. Okay, so first off, use a local setting or a world setting. The world setting is just always going to be kind of more so right in front of you, a always 90 degrees viewpoint of the model. All right, so we can orient the scan. We'll center that on our grid. We might notice here, as we zoom in, we can actually see the blue indications that this clinician had given us through the 3D scan. So they drew over, likely over the patient's liner, where actually this was a scan of a mold. I'm sorry, this was a plaster mold that they drew on it. So with an OBJ file, we're able to see this color. This is extremely helpful for us being able to do clinical modifications as well as adding in some of these cushioned areas for you, as well as indicating some trim lines if you don't have a more demarcated line there. So looking at this scan, again, let's talk about what a good scan looks like and what maybe a bad scan looks like. This would be, I would classify this as a good scan because as I look at it, there are no large indications of a hole in the scan. So a hole in the scan would look like an open area with this blue demarcation toward the top, and it would be somewhat, right in the middle of the actual scan itself. There are ways that we can repair that scan. However, the better scan that you give us, the more that we're going to be able to do with it, and it's going to be much more accurate. For the colloquial term of crap in, crap out, we have to have a good 3D scan to start with in order to deliver a good product. So we're going to be just, again, generally looking at this 3D scan, how we're looking at this in a 3D space, is just something to get used to. How do we know that this 3D scan is actually scaled properly and it's large enough? Here up in the View tab, I have a Show Printer Bed option here. So I have input the dimensions for the PVA-Med Emergence Pro V2, and I know that generally speaking, within this bounding box, this 3D scan would be of the relative size that it should be. If I want to take a look at actually seeing the scale of the model, we do have an analysis tool here, and we can look at the units and dimensions of the part itself with bounding boxes, but these are the only measurements that Mesh Mixer is going to give us. So while Mesh Mixer is a good tool for looking at 3D scan data, it's not sometimes the best to do our clinical modifications within this software. So taking a look at now the window capture mode here for Chrome, and why are we not, let's see, having some technical difficulties, can't even see my cursor anymore. Gotta love our live feature here. Okay. Let's try this again. If I can find my cursor. Sorry for the technical difficulties. All right. So we should be seeing Google Chrome now. Let's see if we can actually get through this here. So let's go through some different 3D scanning options, right? One that a lot of people are familiar with is the structure scanner, structure sensor, technically. So the structure scanner, the Sensor Pro here, is the newest option for structure by occipital. Let me just see if we can grab the cursor. You can see that happening here. Maybe. Yeah. All right, let's try this again. Okay. Now we should be able to see the cursor. Again, thanks for cooperating with my technical difficulties today. All right, so we have the structure scanner, Sensor Pro, their brand new scanner for the back of an iPad. I have to say that the structure sensor has not been the most reliable in the past for, say, a below the knee amputee, above the knee amputee, lower limb orthotics. I would argue in some cases some foot orthotics, just not having the detail necessary for some of these smaller objects that we're trying to scan. If you were scanning for scoliosis, say a larger object that you're trying to scan, the structure sensor Mark 1 and Mark 2 worked a little bit better with larger objects. Their calibration has been notoriously difficult to use, but since they've gone up to the Pro, they hopefully have worked out some of those kinks. I have not used the Sensor Pro myself yet, but I know that a couple of my customers are moving in that direction just because of the inconsistencies in circumference measurements that they were seeing with some of their scans. So again, you kind of get what you pay for when you're looking at 3D scanning. So if we take a look at what this would end up costing you, if you're going to end up buying an iPad, I'm looking at the oldest iPad, maybe the cheapest option, was about from 2017 and about $250 for the iPad itself. That would be the lowest end that you could possibly go, and then about $700 for the actual Structure Sensor Pro scanner. So you're really looking at about $1,000 for this whole getup. You can right now, if you have the Structure Sensor 1, you can trade up to the Sensor Pro with a $100 trade-in value. Maybe a good value for what it's worth. Again, if you're scanning larger objects, in my experience, the structure sensor has been adequate in doing so. If you're scanning more fine objects and you really want to get the detail necessary for a good quality scan, I would actually take a look at a different scanner here. We're going to take a look at Comb Scan. So Comb, working with these guys very, very closely. These guys are awesome to work with. Stefan Purington and Alex Goodman over there, as well as John Naft. These guys have developed a 3D scanner software app on an iPhone 10 or newer. And from my experience clinically, this is the most efficient time-wise and money, as well as being able to get extremely detailed and accurate scans within increments of plus or minus 2 millimeters of accuracy. I have seen that even the Structure Sensor Pro is up to plus or minus 4 millimeters of accuracy, which is still a little concerning. So everybody that I talk to that is looking for a scanning solution, I am pushing them towards comb because it was what I was most comfortable with in the clinic, most convenient. You know, an iPhone in your pocket with an iPhone 10 or newer. It was easy to get up close and personal to that individual, and it was much more focused towards the prosthetics and orthotics fields. There are some other apps out there that have some of the same background technology, but Comb has internal algorithms here to specifically target toward the prosthetic and orthotic fields and have different bounding boxes depending on what you're actually scanning. Typically right now, you know, this solution is about $750 a year per user. And looking at a basic iPhone 10 that you could purchase through Walmart or Amazon would be about another $250. So again, all in dollars for this solution. Now getting into something maybe a little bit more heavy, if we go toward Rodin 4D, they have a different type of 3D scanning technology that utilizes more of the higher end 3D scanners. Let's see if this will load. Rodin 4D as well as Vorum will have a very similar solution for 3D scanning. Looking at their M4D scan, you are attached to a computer at all times, so it does limit you in some senses. But what's nice about some of these software and hardware solutions is that when you have the patient model in front of you, such as a squirmy baby, they can be moving around slightly, and you can still track that same scan within, you know, less than a millimeter of accuracy. So the higher end 3D scanners such as this from Rodin 4D or Vorum as well, these are going to be the higher end in financial value for the scanner. But in some cases, maybe you would argue that they're slightly more accurate than something like Comb. Honestly, for the applications that we have, the Comb app is extremely detailed to the degree of what we need for prosthetics and orthotics. So again, just some different options here for 3D scanning capabilities. Vorum, Rodin 4D. If you want to get something that's a little bit more nondescript and just strictly something like that scanner, it works off of the Peel 3D scanner platform. Peel 3D, looking at the Peel 2, this would be, again, one of your more high-ticket items for a 3D scanner such as this. You know, but for different levels of accuracy, you know, again, maybe $8,000 you're talking about for a 3D scanner solution. Again, maybe that's worth it for your clinic. You have the availability of funds to do that, and you're really focused on getting less than a millimeter of accuracy. Sometimes that's needed. So when we're talking about cranial remolding helmets, I would argue that this is definitely the way to go. All right, so we've gone over some 3D scanning solutions. Let's start to go over some clinical modification software solutions. So through PVA Med, the Emergence Pro platform, they do have, along with their 3D printing solution, they also have their modification software, Rapid Plaster, where you can modify within their software strictly for test sockets for lower limb prosthetics. Below knee, above knee sockets are going to be, fairly streamlined in this process to be able to modify partially quantitatively, mostly qualitatively in your modifications, but still a very usable software and very specific towards their solution platform. They also suggest using Comb, and you can purchase their entire 3D printing platform with all these solutions included. Looking toward another option would be Spenpiece. Spenpiece out of Belgium. These are also some very up-and-coming individuals within this space. The Spenpiece platform has been in the past organized towards upper limb orthotics, but they are now getting into lower limb orthotics as well. They pride themselves on being partially agnostic to 3D scanning and 3D printing solutions. So you can have basically any 3D scanner can import a 3D scan into their software, and you're able to modify that software directly on your iPad. I have used it myself a couple times, and it's a very straightforward and more clinically friendly software than some other ones for upper limb and lower limb orthotics at the moment. But we are looking at some lower limb prosthetics options. We've heard from them that they're looking towards that avenue to be able to integrate that within their software as well. So you do have a desktop version of the software to manage all of your patient data, and then having the iPad to actually modify those 3D scans on there, and then creating the actual device around it. Another software that is currently up and coming at the moment is known as Mercurus. They have a slightly similar software to Spenpiece. I have not used their software as much, but they would be possibly somebody else to look into and look at their options for their digital rectifications for clinical modifications. I know that they've been involved mostly in resting splints, resting AFOs, if you will, but it seems like they're getting more into some lower limb orthotics at the moment. If we look at some older technologies that are still in use today, the Omega scanner and clinical modification software solution by Ohio Willowwood has been used in the field now for years. They also use a 3D scanner, white light scanner, to that's similar to the Peel Vorum Rodent 4D style. Again, probably going to be a little bit more pricey for this solution, but again, depending on what you're looking at doing, would be useful and worth it for you to get into. I have seen the software myself and partially used it with another clinician. Does look like a more straightforward modification software for all solutions, prosthetics, orthotics, cranial remolding, TLSOs, you name it. So that would be a quick run through of now different scanning technologies that you have available, some different 3D modification tools, clinical modification tools that are available. This is not an exhaustive list, only in our half-hour webinar here. This is kind of just touching the surface of kind of what is available and out there for people. So we will be getting into a lot more detail, as the weeks go on, and we can also, take advantage of any questions you may have and get really down to the nitty-gritty of how to use these softwares. We can do very targeted one-on-one training opportunities with you folks. If you're interested in looking at some of these solutions, we can help guide you in that right direction through Ascent Fabrication. Also through Ascent Fab, you have the option of strictly, just sending us a 3D scan. And then we actually use the PVA Med Emergence Pro platform in-house to rectify some of our modifications for prosthetics. And then we have their 3D printer in-house. While we're talking on the side of 3D printers, for the FDM solutions, or FFF, FDM being fused deposition modeling, FFF being fused filament fabrication, those are interchangeable with 3D printing and additive manufacturing. Additive manufacturing is kind of the blanket term. And then underneath that, we have the layering process, FFF, FDM. If you're looking to get into higher end industrial solutions, we also support that at Ascent Fab for selective laser sintering, SLS, or HPMJF with PA12 nylon and PA11 nylon as solutions that you could use for products. A different 3D printing platform also to take into account if you're looking at large scale 3D printing would be Filament Innovations. These guys absolutely are doing a wonderful job with getting large-scale 3D printers at affordable solutions here for prosthetic and orthotic clinics and wonderfully built machines. I'm actually going to be going to visit them myself here in just over a week to work with these guys a little bit more on some of the materials that we're using in-house here at Ascent Fabrication. So again, guys, thank you very much for taking this time with me today. We are going to be at the New York State American Academy Orthotics and Prosthetics meeting in Schenectady, New York, to give a presentation on a little bit more detail for what we just went over today, different 3D scanning, clinical modifications, and 3D printing solutions. Today we didn't quite get into materials, but that we will expand upon that in a further Fabrication Friday webinar. So thanks again for spending the time with us today. Feel free to reach out as well. Check out our website, ascentfab.com. We're on LinkedIn.